finish this little warm-up here. We'll go from current slide. All right. Now, there was a question. I wanted to get this on Screencast-O-Matic. I should have waited to answer it. But on test 3, question 11, it says use this graphing utility. If you got one, you can certainly use it. If you don't have one, just multiply it through, do whatever it takes. You'll find that form factors. When you factor it, you come up with equations in sine or cosine, and then you can, I think they're all in cosine if I'm not mistaken, and then you can solve those using inverse cosine. So you don't have to have the graphing calculator, but you do need a calculator that does inverse trig functions. Okay, next question. How many have done the student course evaluations? All right, 2, 3. Need everybody, folks. Please get the student course evaluations done. Okay? See, it seemed like there was one other thing along those lines I meant to ask, and I can't remember it now. I do want to tell you about this, though. Normally, I have office hours on Friday on the Birmingham campus, 7:45 to 11:45. Not tomorrow. Tomorrow, I do have an infusion scheduled. I'll be at the Kirkland Clinic from probably before 7 o'clock until probably around 4 or so. So, no way I'll be on the Birmingham or Bessemer campus, either campus, at all tomorrow. So, don't come looking for me. Okay. I guess I ought to say these two. I do need everything turned in by next Thursday, 1 week from today. Now that includes your research papers. I would say about half of you have turned those in. Good for you. The other half, I need those, okay? Earlier rather than later, okay? And by the way, today is the last day, being the 30th of November, to get that one extra leftover bonus point. If you get it to me today, I can give you that bonus point. If not, you're not going to get a bonus point. But if you don't get it in by next Thursday, you'll start losing points. So get it in today if you can, anytime. If you are on campus tomorrow, I won't be. You can slide it under my door. I'll pick it up Monday morning. I'll be on campus all next week, but I have to have those by Thursday, by the beginning of class on Thursday. Okay, get your research papers in. The first test, I thought I could return these to you. Did I return them to you? I didn't. Okay, I thought I was going to until the one person who hadn't done it showed up last time and said she was going to get it into me today. So she's not here yet, so if she does get it into me, I can return those to you. The second test, most of you have done it, but some have not. In fact, I may be preaching to the choir, I think. No. Some of you are still working on it. So, well, I got one in today, so I guess all of you have got it in, but I've got several people who have not turned it in. And test 3, I only have one who has turned in test 3. So try to get those in to me as well. And I will be returning all those to you on Thursday, 1 week from today, and I'll be giving to you your last test, which will cover chapter 6 as much as we cover in 6, plus the final exam, which will be comprehensive. I'll give those both to you. They'll be shorter than the first 3 tests, guaranteed, okay? In fact, they're going to be about, I think it's around 10 questions each, and pretty short, pretty quick. You should be able to get those done easily within a week. Okay. Any questions? All right. Where we left off last time was area of a oblique triangle. This is chapter 6, additional topics in trigonometry. 6.1, law of sines. We're finally going to finish this section today, I hope. And this is area of an oblique triangle, which really doesn't use the law of sines, but it uses something that has a sine in it. So that's why they put it here. Okay? But the procedure used to prove the law of sines leads to a simple formula for the area of an oblique triangle. Okay? That. Good deal. Thank you. Or did it Don't answer that question. All right. All right. So, remember how we set up the law of sines to begin with? We dropped that perpendicular down there, whether it's an acute or an obtuse angle. And what is that H? I mean, it's given the term H. That's the height of a triangle, right? Okay? So, if we know a base, like C, okay, and at least one of these two angles, A or B, okay? I think that's enough, yeah. Then, if you know this base and one of those two angles, then you know that the area of a triangle is 1/2 the base times the height, and that is the height. So if you know the length of the base, C, and you know one of these angles, okay, either one of those two angles, then, oh no, you'll need one more thing. You need another side. If you know this angle, you need side B. If you know angle B, you need side A. Sorry, you do need that. And if you have that, then the base, the length of the base C times the height, 1/2 the base times the height. What is the height? That is sine of A is H over B, or sine of B is H over A. Either one of those. You set it up just like you did law of sines, and then so H is equal to B sine A or A sine B. Either one of them. So 1/2 C times B sine A or A sine B. And that's what we've got here. Referring to the triangles below, note that in each triangle has a height. H is B sine A. So if you know that and you know the base, then you know, well, they don't write the whole formula. That's going to be on the next slide. Okay, so here it goes. Consequently, the area of such a triangle, 1/2 the base times the height. So that would be 1/2 C, if you know C, times B sine A, or 1/2, and they rearrange it here, 1/2 BC times the sine of A. Okay? You get it from the same source as you do the law of sines, the same, it shows it that way, and it has a sign in it. It's not really related to the law of sines, but it is. By similar arguments, you can develop the other formulas. If you know the base A, if that's your base, then your height would be 1/2 B sine C or 1/2 C sine B. So there's two others that you can use. And Justin's here. All right? And there is one more. They didn't list. I don't know why. So if your base is B, then the area is 1/2 B times well, you just have to turn it around. This is BC sine A. It could also be AC sine B. Okay, those two, these two, and then the other one, just flip them around the other way. Flip the triangle the other way. So you have, this is the base, okay? Then you would have B times 1/2 B times A sine C or C sine, C sine B, C sine A. So either one of those, any of those will work. All right, I think in the book they list all of them. Yeah. Okay. And it basically comes from the law of the same arguments that gave you the law of sines. So let's see. Here they are. Okay. If I'd go one more slide. The area of any triangle is 1/2 the product of the lengths of two sides times the sine of the angle in between those two sides. That's what it gets down to. So that's going to be 1/2 B sine A, 1/2 A sine A. I'm sorry, 1/2 BC sine A, 1/2 AB sine C, or 1/2 AC sine D. Any one of those will work. And that's why on the previous slide we already had them all. Note when the angle A, or any of the angles, is 90 degrees, or if the angle is 90 degrees, then the sine of 90 is what? Sine of 90 degrees. What? Okay? So that would be 1, so it's 1/2 the base times the height. Well, B would be the base, C would be the base, B would be the height. So yeah, that's exactly your formula. You have the formula for a right triangle. Okay? And here it is. Okay. Similar results are obtained if angles C or B are equal to 90 degrees. They all work out the same. If C was 90, 1/2 AB. Okay, if B is 90, 1/2 AC. Now, I think they're going to have, here's example 6. Find the area of a triangular lot having two sides of length 90 meters and 52 meters, and the included angle is 102. Let me get my pen set up. I wish I'd have taken a little break between my two classes. My last one was finishing a test, so I was in there the whole time. My stomach is growling. I wish I'd have grabbed a little something to eat, but I didn't. All right, so here we have an angle of 102. So we'll have that, that's just slightly more than 90. So we'll call this 102 degrees. Okay. Let's make this A down here of 90 meters. Pretty big lot here. Okay, B up here. Whoops, that's a little b. Little b is equal to 52 meters. And we're going to assume this side, this angle down here is angle C. Okay? Yeah, C is 102. There's the other leg of the lot. Now, my angle probably isn't exactly 102, but get the general idea. Okay? You don't need any other information than that. And what would that give you as the area of that triangular lot? What's the formula for it? Okay, that's law of sines. This is the oblique triangle, area of oblique triangle. I've been talking about for the last 13 minutes, 10 minutes. Okay. What's the formula? Guess I could have been up here, goes on blah, 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 blah. What's the formula for the area of an oblique triangle? Well, any triangle. They call it an oblique triangle. That means not 90. It works if it's 92. But what's the area? 1/2. Base times the height. And what's your base on this one? Yeah, A. I'll put the A down here. And the height would be B times the sine of angle C. So this will be 1/2 of 90 meters times what is B? 52 meters. And then the sine of 102 degrees. I can't write. Okay, so if you pull out your handy dandy calculators, see what you get. Anyone? Frankly, I would do half of 52 would be 26. That would be 90 times 26 times the sine of 102. What you get? Say again? It doesn't seem right. I couldn't hear what you said. Okay, well, say it one more time. 2,289? That's exactly right. That would be approximately 2,289 square meters. Okay? Notice you got meters times meters gives you square meters. So that's exactly right. Now, what didn't seem right about it for you? Too big a number? Well, if you think about it, if this were a parallelogram, okay, just flip this over across that line, make it a parallelogram, that would be the base times the height, not the leg. But that's not too far off from what that would be. So let's just say 90 times 50 would be 4,500, and half of that would be 22,500. Not too far off there at all. 50 times 90, 4,500, 2250. That's 2289. So not bad at all. Okay. Any questions on that? By the way, there is a checkpoint. Generally, after every example, there's another checkpoint, and there's an audio-video solution for that in English and Spanish at larsonprecalculus.com, every one of them. And I think the checkpoints also have the answers in the back, okay? So if you don't have a computer, you can still look at the answers in the back. All right, any questions on that? Let me clear this out of the way so that we can see how they did it, which I think is going to be pretty close to what we did. Consider A is 90. Oh, their picture is not quite as pretty as mine, but close. And B is 52, and the angle between is 102. Mine was a little bigger than that, but it was just representative. Okay? The area of the triangle is 1/2 AB times the sine of C. That's the formula for the angle, area of an oblique triangle. Okay? So that'll be 1/2 90 times 52 times sine of 102. I kind of like putting units in so you make sure the answer is making sense, and it does. It's about 2289 square meters. They wrote out square meters. Meters squared would be a perfectly good abbreviation. Any questions? All right, there's at least one application. No, there is one application here. The course for a boat race starts at point A, up there at the top. Point A. Proceeds in the direction south 52 west to point B. So what that means, you point to the south and then move 52 degrees to the west. And that gives you this, head down this way to point B. Now they didn't tell you how far you go to point B, you just go to the buoy or something that's there at point B. Okay? Then, in the direction south, 40 degrees east to C. So at B, when you go around that buoy, then you head south, but 40 degrees east of south, and that has you heading toward C. Okay? Now, finally, you go back to A, as shown in the figure there, and you know that point C lies 8 kilometers directly south of point A. Approximate the total distance of the race course. Okay? Now, They drew a point D here. You didn't actually have to have it any place here. They just drew it in here because that's due south to give you something to measure 40 on. They had done that too, but that just happened to wind up where C was. So that wasn't part of it. So here we have a triangle. We know this angle. We don't know either one of the other two angles, but we know an angle that has something to do with this angle. Now, what does that have to do with that angle? Well, that's sort of difficult. What does that 40 tell you more about? Does it tell you more about angle B or angle C? It's adjacent to angle B, but it's hard to get any useful information out of that. What does it tell you about angle C? Any idea? That's 40 degrees too, because those are called alternate interior angles. Since this is due south of B, this is due south of A, then these are parallel lines here, and a transect that crosses two parallel lines, the alternate interior angles or the alternate exterior angles are all going to be equal. So that makes C 40 degrees. So we do know something more. This C here is 40 degrees. Okay? And Terrell decided to show up today. What a joy. Okay. All right. Just got to find you now. There you are. All right. Has anyone else come in since I called roll? 3, 6, 8. Yeah, got it. Okay. So now we know something else. All right. Can we come up with the total distance of the race course? I know one leg is 8 kilometers, but I don't know the other two. Is there any way we can get those two? All right. Any way we could get length C or length A? That one over there, the 8 kilometers, by the way, is length little b. Say again? Yes, exactly. How? That would give you lengths, and yeah. Yes, it becomes 180. So add up these two, which is 92, right? Subtract that from 180, and that gives you 88. So angle B is 88 degrees. Anytime you know two angles, you know the third one, okay, of a triangle. So that's 88 degrees. Now we can figure out the other two. And how do we do that? Once you knew what angle B was, you now have a ratio that you can use in the law of sines. What's that? I thought the law of sines only worked with right triangles. It does. And that sets up a ratio you can work with. Okay, so you tell me how to go. What's that? Okay, you don't have to have a right triangle. That's it. The law of sines, law of cosines lets you work on oblique triangles. And how does this work? You were starting to give it to me in the last problem. Okay, you want to go for little a over sine of capital A is equal to little b over the sine of capital B. I like that because I know that ratio, 8 over sine of 88. I don't know exactly what it is, but I have the values for it. And on this ratio, I'm only missing the A. This, by the way, is your A down here. That's the second leg of your race. So this will enable us to get that because we know capital A is 52. So let's solve that for little a. So little a is equal to b times the sine of capital A divided by the sine of b. Okay? In other words, I just multiply both sides by sine A and put that ratio in place. And now you can plug in, you chug there, let's plug, and this will be 8 kilometers times the sine of 52 degrees divided by the sine of 88 degrees. Anyone get that answer? Excuse me. Anyone get the answer? Louder. Second. 6.3. You know, we'll let that go with 2 digits here. This is approximately 6.3 kilometers. Okay? Now, does that make sense? Your biggest angle is opposite the longest side, 8 kilometers. This is the second biggest angle. It's opposite something that needs to be less than 8. 6.3 seems reasonable. All right? Now what? What's that? Are we interested in finding the area of the race course? What's that? That's all we're doing is total distance. How far you travel. We do one leg, we're just looking for the other 2. We got one of the 2. Can we get the first leg? A little louder. Excuse me, I can't hear what you say. What's that? Excuse me, I can't hear what she's saying. Okay? Okay, go ahead. Okay, we go back to the ratio that we know, B over sine B is equal to C over sine C. Okay? We know the ratio B was 8 over the sine of 88 degrees, and that's equal to, we don't know what C is, so that's an unknown here, and the sine of C would be the sine of 40. All right. So what is little c then? It's equal to 8 times the sine of 40 divided by sine of 88. Okay. Now, actually, what we could have done if you had looked ahead far enough to do it, you could have just figured this one. And once you had this one, just plug that in and multiply it by the sine of 40. Since you probably didn't do that, tell me what that is. 5 on the nose, 5.1. So this will do approximately 5.1 kilometers. Now, does that make sense? The 8 kilometers is opposite the largest angle, so that should be the longest. The 6.3 is opposite 52, that should be the middle. This is the smallest angle, that should be the smallest leg. It is the smallest leg. Doesn't tell you if the answer is right, but at least it tells you you're in the right ballpark. So then what do we have to do? We won't add them together. 5.1 and 6.3 would be 11.4 plus 8 would be about 19.4. So the approximate distance of the race course is about 19.4 kilometers. Okay? by the time you turn around the buoys and stuff like this, I bet you go at least 19.5 kilometers, but we'll let it sit at 19.4. They did 19.46. I really don't think you have justification for keeping more significant digits than that. In fact, you could argue that should only be one significant digit, 6 and 5, okay? But since you did have angles with 2 digits, I let you go and use 2 digits for that. But your length here is only 1 digit. We really shouldn't be beyond 1 digit. But we can live with that. Any questions on that? All right. Let's see how they did it. Let me clear the screen. I guess I don't know for sure if they're going to use the same screen. Nope, they go on there. Because those lines B, D, and AC are parallel, it follows that the angle BCA, that was your 40 degrees, was equal to angle CBD, which was the angles. Well, actually, BCA is angle C, and CBD was the one they gave you, 40 degrees. So we know those are 40. BCA was 40. And you have the opposite side. Well, you can't do law of sines unless you have a ratio. You don't have a ratio there, but it's really easy. Anytime you have 2 angles over a triangle, you know the third one because the sum is 180. So that gives you 88 degrees. And once you have that, now you have the ratio you need, 8 over 88. And here's the law of sines. And use the one you know. Use this one. You know that angle. Use this one to get A. Use that one to get C. And that's exactly what we did. 8 over sine 88 times the sine of 52 is A, which is about 6.31. Which they don't really have the precision in the problem to give you 3 digits, okay? And then C would be 8 over sine 88. Good deal. Thank you. Have a good weekend. Okay? And that would be, multiply that by the sine of 40, and you get about 5.15. Again, you don't have enough digits to do that. And did we say 5.2 or 5.1? I can't remember. They may have rounded up to get the 5. Oh, yeah, they did, okay. All right. So that gives them about 19.46 kilometers. We said 19.4 because they rounded one up that we didn't. Okay. All right. Any questions on section 6.1? There is a summary there, well worth your reviewing that summary. Let's do the vocabulary. Okay? Number 1, and blank triangle is a triangle that has no right angle. Say again? No, obtuse means greater than 90. It's another O word. Oblique. An oblique triangle has no right angle. Number 2, for triangle ABC, the law of sines is A over sine A is equal to blank, which is also equal to C over sine C. B over sine B. Very good. Number 3, 2 blanks and 1 blank determines a unique triangle. 2 blanks and 1 blank determines a unique triangle. Any ideas? Triangles made up of what? 2 angles and 1 side, because if you know 2 angles, you know the third angle. And then you have a possibility for law of sines. Number 4, the area of an oblique triangle is 1/2 BC sine A, which is also equal to 1/2 AB sine C, which is also equal to what? To what? 1/2 AC sine B, is that what you said? Yes, correct. All right, now I gave you some of these before. I'm going to repeat those. I would do either 5 or 7, or both, and then do any of the odds 9 through 23. All those odd exercises are at calcheck.com. Then do any of the odds 25 to 33, any of the either 35 or 37 or both, any of the odds 31 to 45, and then on the word problems or application problems, and by the way, the 39 to 45 are the ones we did today on the area of an oblique triangle, and then the word problems 47 through 55, those would be more like that last application we just did. Okay, though there were some others in there too that were similar to it. All right, they have a 2 true false, odd true false. I don't know if those answers are in the back or at calchat.com, but at least they're worth looking at to see. And number 61 is another pretty good problem to look at. Any questions? 6.1, Law of Sines. Any guess what we're going to go to next? Law of cosines, okay? And that will be 6.2. If we can get the PowerPoint to come up. All right. We're almost there. Okay. So chapter 6 is additional topics in trigonometry, and 6.2 is the law of cosines. Now remember, we had several cases. Some of those cases law of sines work, either all the time or most of the time. There were some cases though law of sines will not work. You do not have enough information. Remember, for the law of sines to work, you have to have one ratio of the side and the opposite angle. You have to have that, the angle and the opposite side. You have to have that. When you have 3 sides given, there's no way you got an opposite angle. There's no way you can get it. So that's one way, one case that you're going to need the law of cosines. The other case is when you have 2 sides and the angle in between. Now, if you have the side-side angle, law of sines may work with that if it's got a unique triangle. Because the side, and another angle, you'll have an angle in the opposite side. Okay? So law of sines should work there if you can. But if you have a side-angle side, the angle in between the 2 sides, there's no way you can get that other side and no way you can get another angle. So again, law of cosines will work for that. Then we'll use the law of cosines to model and solve some real-life type problems. And then there's another area formula that does not require an angle. All you need is the 3 sides, and that's Heron's area formula. Now, it really has nothing to do with the law of cosines, except it's a side-side situation, so they threw it in here for that. I can remember back when I was in high school, they called this Hero's area formula. I think later, since then, they found out the guy's name wasn't Hero, it was Heron. Okay, someone had mistyped or something, and they didn't. So if you ever see it specified as Heroes, that was from the old days. It's now Heron's. Okay. So, 2 cases remain in the list of conditions needed to solve an oblique triangle. We did angle, angle, side. We did side, side, angle. And we did side, angle, side, angle. All 3 of those, you can use law of sines if they're solvable. These 2 you cannot use law of sines. When you're given 3 sides or 2 sides and the angle in between, the sassy ones, okay, none of the ratios of the law of sines will be complete, so you can't get started on the law of sines. So now we use the law of cosines. Now, law of cosines is just a little more involved than the law of sines. Law of sines is just a set of ratios. They're really easy to solve. Law of cosines, a little bit more. You have some squarings, you have some products, and you have, of course, some cosines. Okay? And there are 3 standard forms you can have for it, and then 3 alternative forms you can have for it. If you're looking for the side, you know 2 sides and the angle in between. This is side, angle, side. If you know that, this is the form you'll use. So they call it the standard form. If you're looking for A, you can't just find A, you have to go for A squared. Okay, this makes it a little more complicated than the law of sines. A squared is equal to B squared plus C squared minus 2BC cosine A. So again, a lot more complicated than the law of sines. Number 1, you got your sides are squared, and number 2, you've got a product of 2 sides times the cosine of an angle, mixed in there too. Now, what does this look an awful lot like? Especially this last one. What does that look like? Pythagorean theorem. But the Pythagorean theorem requires that angle to be a 90 degrees. And what is the cosine of 90 degrees? Say again? 0, is that what you said? 1? No, sine of 90 is 1. Cosine of 90 is 0. So if it's a 90 degree triangle, cosine of C is 90. Cosine of C is 0. That does give you Pythagorean theorem. So here's another way to get Pythagorean theorem from the law of cosines. Of course, it's easier to remember that than law of cosines. All right. Now, if on the other hand, you're given 3 sides and you need to find an angle, okay, then this is the alternate form. And what you do, you add this to both sides, subtract this from both sides, so that gives you B squared plus C squared minus A squared is equal to 2BC cosine A, but then divide by 2BC, and that gives you cosine A is B squared plus C squared minus A squared divided by 2BC, or any of the others, okay? So again, the law of cosines are a little more complicated looking, maybe a little harder to remember, but really not that bad. It looks like Pythagorean theorem, whichever order you want to write things. A squared is equal to B squared plus C squared. But then do a minus 2 times these 2 lengths, B times C, times the cosine of that angle, A. Or AC cosine B. AB cosine C. Okay? Or if you're doing the alternate form, when you're trying to come up with an angle given 3 sides, the 2 that are added, that goes down here. The one that's subtracted, that's out here. And again, just like that. That's the law of cosines. Now, there is a little rule that you need to do if you're doing the law of cosines. Because it looks like you can name the sides anything you want to, right? No problem. Okay? Here's this first illustration is going to give us what we need, okay? All right. First, we'll use the standard form or the alternate form for this. It says find the 3 angles of the triangle shown below. We use the standard form or the alternative form. Say again? Say again? Now, if you use standard form, you need to know the angle. We don't know any of the angles. We know the 3 sides, so we're going to use the alternative form. Okay? Now, let's flash back here. Which alternative form will you want to use here? There's nothing that's told you this before. I'm telling you now. Do you have a guess? Which one you want to do? Oh, sorry. Do you want to use the cosine A, cosine B, or cosine C? Yes, go for the big one, okay? Because there could be ambiguity here if you went for one of the small ones. If you go for the big one, that's going to get you. So you tell me what the cosine B would be. B, okay? Whoops, let me get my pen activated again. Okay, so cosine B is equal to what? A squared plus what? I can't hear. C squared minus B squared over what? 2AC. Perfect, huh? It is a quadratic equation. Is that what you said? It's not the quadratic formula. Okay. It is a quadratic equation because it's got squares in it. But this is what you do. Okay? The thing that's here, the angle that's here, the only place that side shows up is over here with the minus b squared. Everything else is your AC. A squared plus b plus c squared and divided by 2AC. Okay? So now we can plug and chug, folks. So, what's your A? So 8 squared is 64. Now I'm going to go in and write the units in for now. You really don't have to, but that's square feet because you square the number but also square the angle. Now I don't happen to know that right off the top. What is C squared? 14 squared I think is 196. If someone's got a calculator, would you punch it in quickly? 14 squared? Okay, 196. Okay, 196 square feet. Okay, minus, and what's your B squared? Ooh, I do need a calculator on that one. What's that? I can't hear. 361? Yeah, 361 square feet. Okay, divided by 28 times 8, right? 2 times 8 times 14. And by the way, those are feet and feet down there too. Okay? What's that? 234. 64 feet squared plus 196 feet squared minus 361 feet squared divided by 2 what? 224 square feet. Okay, because feet times feet is square feet. All right, add these together. 64 and 196 will be 0, 16, 2. Minus 361. Whoa, a negative number here. Okay, that's fine. What does that come up being? You've got a calculator, I don't. Second? Negative? Okay, negative 101. That's that only on the top. Is that right? 101. I can't write. Square feet. Divided by 224 square feet. Okay? That's a 101. My writing is terrible. Okay? And what does that equal? Negative 0. What? 45. Okay, now, notice your square feet cancel out. They disappear. Which is a very good thing because a cosine should not have a unit on it. Okay? It's a ratio, a perfect ratio. Okay? So what do we do now? If that's cosine of B, cosine of B is equal to negative 0.45. Say again? Take the inverse cosine, excuse me. Inverse cosine. What's the inverse cosine of negative 45? What's the inverse cosine of negative 45? Second? It says an error? Huh. That shouldn't be. Because cosine can have a negative angle. You see that? Okay. Get? Okay, 117 degrees. Did everybody see that? Anyone else get an error when you tried it on your calculator? He said he did. Did you get an error also? Okay, now what her error was, when she entered this sign here, she used the subtraction key, not the minus C in parentheses. Which one did you use?
I did the same thing.
You did the same thing? Okay. Use that subtraction key. The other thing, what I would have done, folks, when you did this subtraction, this division here, whatever you wound up with, that's the right key. Just do an inverse cosine of that answer. Huh? What's that? Oh, yours won't do that? Oh, you have to go to the new one. Okay. All right. Too bad. Okay. That would have saved you that thing. So you got what, 117? All right. Now, frankly, we're stretching it a little bit because we're getting three significant digits. We only had one or two. I think we have to allow for the closest degree. Okay? Now what do? That only gives you one angle, angle B. We need the other two angles, A and C. How do you get those? Yes, now that we have an opposite angle, that we have this is 117 degrees, now we can use the law of sines, and that's so much easier than having the square and blah, 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 all that kind of stuff. So how does law of sines work here? A over sine A equal B over sine B. Okay. In other words, we're looking for angle A, so sine A is equal to little a sine B divided by sine A. Okay, now they may not do it quite that way, but no, wait. We know B. Oh, yeah, sorry about that. Wait a minute. I think that's divided by B, isn't it? Yeah, divided by B. Yeah, because sine B over B is equal to A times that. Yeah, that's right. So now, here's what I would have done, folks. I know your calculator won't do it. But whatever you wound up here, if you had used that full thing there, don't change it, and take the inverse cosine of that, that would have given you an angle that went forever here. And then that I would have plugged in and taken the sine of that angle and then multiply it by A, which was 8, and divide it by B, which is 19, and that gives you a number. Hopefully that number is between what? Zero and 1. If you ever get that number to be outside of 1, hang it up jack, because it's not going to work. If it ever comes out being negative, hang it up, because these need to be acute angles, and the sign needs to be positive, okay, and less than 1, okay. So what do you get there? Little a, which is 8 times the sine of 117 divided by 19. What does that give you? .88? 0.38? Okay. Now do an inverse sine of that and see what you get. About what? 22, is that what you said? 22 degrees. All right. That sounds reasonable. Why does that sound reasonable? Because this side is much smaller than that side, so you expect that angle, just like the picture shows, to be much smaller than that, and that is a whole lot smaller. All right? What do we do next? We've got angle B, and now we have angle A, 22 degrees. Law of cosines to get angle C? No, way too much work. Law of sines to get angle C. That's still too much work. You got two angles. Ha! Subtract from 180. Add those together. That would be 139. Subtract that from 180, and you get what? 41 degrees? Is that right? My old brain doesn't work too well this early in the morning. Okay. And guess what? Does that make sense? The biggest, longest side is opposite the biggest angle. The shortest side is opposite the smallest angle. And the medium side is also opposite the medium angle. That sure seems like it's reasonable to me. All right. Let's see how they did it. Again, be lazy. Use the easiest formulas you can. Okay? Number one, it's a good idea to first use the angle opposite the longest side. That was side B. Now, the reason for that, you would otherwise come up with an ambiguous case. You don't want to come up with ambiguity if you can avoid it. Okay? And in this case, we could. If you go for the biggest side, the largest angle first, that's going to, there's no doubt what that angle has to be, then the other two will have to fit. Okay, so cosine B was a squared plus c squared minus b squared divided by 2ac from the alternative form. Okay? Plugging those numbers in, you got a negative number, negative 0.45089. Taking an inverse cosine of that, when you have a negation key there, not a subtraction key. Okay? Excuse me. Okay? Then you get that the angle B was 116.80. We sure don't have precision enough to get 5 significant digits. We're stretching it to say 117. So let's just call it 117. At that point, it's simpler to use the law of sines than to do law of cosines. So sine A was A times sine B over B, and that gave you 8 times sine of 117 divided by 19, and that was about 0.37. What did we get when we did it? 0.38 or 37 or something around in there? Huh? 3.8. So we were really close. And then you end the inverse sine of that, and that has to be an acute angle, and that's going to be about 22.08. I rounded that to 22. Then add those two together, subtract from 180, and your C was right around 41 degrees, which I think is what we found it to be too, right? I thought I wrote all, oh, I had to erase it, that's right. Sorry, can't go back and reproduce it. All right, but that I think is what we got. We just rounded to 41. Any questions on using the law of cosines? Tell me, are we already out of time? Man! Well, we got started a little late because of the last class. There is a checkpoint there after example 1. We'll begin next time with example 2. Okay? Oh, actually we'll get started with this slide right at the top. We already talked about it, but we'll start at the slide at the top. Good deal. Homework exercises. Besides the one I just gave you in 6.1 and 6.2, you can do any of the odds 5 through 11, and I think you can do any of the, well, let's see. No, do either 5 or 7 or both. Do either 13 or 15 or both. And stop there and we'll pick up the rest of those next time. What's that?
Do you have the chapter 6 test already? The final. No, not the final. We have a chapter 6 test, then the final.
Okay. Say again your question. I caught part of it, but I missed it.
There's a separate chapter 6 test from the final, right?
Yeah, oh yeah, yeah. The chapter 6 test will be a very short, just whatever we cover, okay, in chapter 6. That will be 10 questions or so. And then we'll have another 10 that's probably 4 from chapter, let's see, I can't remember how I split them up. More from chapter 4, a few from chapter 5, and just a couple from chapter 6.
Yeah, so I was asking if you had the chapter 6 test already, or
I don't know how far we're going to get. I'll have to wait until Tuesday to guess how far we're going to get on Thursday and then hand it out to you then. So I would hate to try to guess now, okay? I probably do have one that'll fit because I've done several in the past. I'll find the one that's closest to what looks like we're going to cover. Yeah, both of them would be your chapter 6 test and your final, comprehensive final will both be take home. They'll both be fairly short. Okay. Good deal. Any other questions? Good questions, by the way. Brittany didn't show. Let me go and end this.